All right, y'all, this is our homework number 12 video. So sorry it's not Miss Keys. I'll get her to guest star eventually. What we're going to go through on homework number 12 is this second problem down here as your example problem. So on this problem, the first question, it says find RPQ. Finding RPQ means finding the measure of this angle right here. So if I'm finding the measure of RPQ, first thing that I always look at, I always have my triangle trig toolkit handy. If I'm looking at this, I notice that there are two angles and I'm missing the third. So that means if I'm looking at my notes, triangle attributes, all interior, oops, you missed that, all interior angles of a triangle add up to 180. That can be used for finding a missing interior angle when given two interior angles. Here, I have two interior angles and I'm finding a missing one. So I can use the fact that triangles are equal to 180 degrees to help me find that. Okay, so I'm going to do part A up here. I'm going to do it the shortcut way. If I know it's 180 is my total, I'm going to take away this angle, minus 70, take away this angle, minus 45. And if I pop that into my calculator, I should get 65 degrees. So my answer here is 65 degrees. Make sure you remember that degree symbol because it is an angle measure. So here I answered part 1, 65 degrees. Okay. Next thing it asks me to find, I'll do this one in another color, but the next thing it asks me to find is PR. PR is a side length. PR is this side right here. I'm going to label this one X. Okay, because lowercase q, I can't write those letters. I'm going to label this X. So I again bring out my triangle toolkit. Already used my first tool to solve all my angles. Now I'm going to look at SOHCAHTOA. The only problem here is SOHCAHTOA only works for right triangles. So if I'm looking at this, there's not a 90-degree angle, so I can't use SOHCAHTOA. So I'm going to look instead at my next sheet at sine rule. To use sine rule, I need to have an angle and its opposite side. So if I'm looking here, do I have an angle and its opposite side? I do. I have the angle 65 and its opposite side of 9, so I know that I can use sine rule here. Okay. This is our equation for sine rule. Reminder that it compares an angle and its opposite side to another angle and its opposite side. So if I'm looking at this, I start with, this is part B, I start with the fraction of what I'm given. Okay, I am given this angle and its opposite side. So sine of 65 over the opposite side of 9. So this fraction is what I'm given. The fraction I want to set it equal to is the fraction that I'm trying to find. Well, I know I'm trying to find this side length that I've named X. I'm going to put X on the bottom of this fraction because reminder, if I put 9 as a side length on the bottom, the denominators have to be the same attribute. They both have to be side lengths. Okay, so I'm trying to find this side length. Its opposite angle is angle 45 here. So I've got sine of 45. Okay, so that's how we set up the problem. In all honesty, to me, that is the trickiest part. So now that I set it up, I'm just going to solve for X. First thing I'm going to do is solve for X. When I see a single fraction equal to a single fraction, I always cross multiply. So if I cross multiply here, that's going to give me X sine of 65 is equal to 9 sine of 45. X isn't totally by itself yet, so I'm going to divide by sine of 65 on both sides. Those will cancel, and I'm left with my final answer. Now, I know a lot of you don't have calculators at home, so if you want to leave your final answer as X is 9 sine 45 over sine of 65, that is perfectly correct. If you pop that into a calculator, you should get X is equal to 7.02. Okay, so you can leave your answer like this. If you put this in a calculator, you should get something along the lines of 7.02. Okay, and that is problem number 1 using our sine rule. Other one I'm going to do on this homework video is this one right here, number 33. The writing is teeny tiny. That's part of the reason that I had chose to do this one, but the majority of what you need you can get from the diagram itself. I'm going to try to zoom in on this, but I don't know how well you can actually see that. What it's asking us to find is the height of the lighthouse. I don't like this question because it doesn't say that this is a 90-degree angle, but we can assume that this is a 90-degree angle. If this is a 90-degree angle, according to my triangle trig toolkit, right, if it's got a right angle, I can use my SOHCAHTOA. So that's what I'm going to do. I'm going to write SOHCAHTOA here. SOHCAHTOA. Okay, I'm going to use 31 as my reference angle because that's the angle I'm given a measure of. This is my opposite side. This is my adjacent side, and this is my hypotenuse. Okay, I'm looking for which one of these am I going to use. Okay. Well, I always start with I'm given the adjacent side. So I know I need a trig identity that has the adjacent side in it. I can immediately eliminate sine. Okay, so I know that I'm given adjacent, so I know it has to be one of these. I'm trying to find opposite, so I need to look for a trig identity that compares adjacent and opposite. The one that compares adjacent and opposite is tangent. Okay, so I'm going to do tangent of 31 is equal to our opposite, which we don't know the value of, we'll call it x, over our adjacent, which is 103. Okay, that doesn't quite look like any of my answer choices yet, so I need to do a little bit of simplification to try to get x by itself. Okay, I always set this up as a fraction so that I can cross multiply. That'll give me x is equal to 103 tangent 31. Now that looks like one of my answer choices. My answer choice is E. Okay, so that is it for the front of the homework, sine rule. We are now going to flip to the back of the homework, cosine rule. And I'm going to zoom in. We're going to do this first problem here. Okay, so this is going to be our example problem. My first question here says find dB. So I'm trying to find the length of this side here. I always label it as x. Okay, so I'm going to run through my toolkit and see what I can use. I really can focus on just this smaller triangle here when I am finding this. I don't have to look at this big triangle just yet. Okay, so if I'm looking at this and I'm running through my triangle toolkit, I say, okay, well there's no 90-degree angle, so I can't use SOHCAHTOA. Next thing that I'm going to look at is sine rule. Sine rule means I have to have an angle and its opposite side. Well, here I have an angle, but I don't know the value of this side. Don't know the value of this angle, but I do know the value of this angle and its opposite side. Because I know the value of this angle and its opposite side, I can find the length of dB using my sine rule. Okay, so I'm going to do that one down here. Remember, I do my fraction of what I'm given, or which one helped me determine it was sine rule. I'm given this angle and its opposite side. Let's put the sides on top this time. So 11 over sine of 100 is equal to the fraction that I'm trying to find. The fraction that I'm trying to find is this angle, or this side, and its opposite angle is this one. Okay, so I'm going to write this as x. It's got to go on the top of my fraction, sine of 59. Again, I've got a single fraction equal to a single fraction. So what I'm going to do here is cross multiply. I get x sine of 100 is equal to 11 sine of 59. Got to get x totally by itself. So I'm going to divide by sine of 100 on both sides. Sine of 100 on both sides. This cancels. You can leave your answer like this, but if I pop this into my calculator, I get x is equal to 9.58. That's what I'm rounding it to. So this side is equal to 9.58. Okay, that answers part one of my question. Part two of my question says find DC. Let me get another color pen for that. Find DC. Okay, so now I am looking for, I'll use y in this case so we don't confuse ourselves. Now I'm looking for y. Okay, I know I can't use SOHCAHTOA because I don't have a 90-degree angle. Let's check for sine rule. I know an angle, but I don't know its opposite side. So sine rule is not going to work here. I have no angle side pair. So that means I'm going to have to go to my cosine rule. Now remember, for cosine rule, there are two different ways that we can write the formula. The formula when we're trying to find the side, a missing side, and a formula when we're trying to find a missing angle. Here, I'm looking for a side length of DC. So I'm going to use the format of the formula where I'm looking for a missing side. Okay, so I'm going to write that one down here as part B. My formula when finding a missing side for cosine rule is right here. I'm just going to write it down. C squared equals A squared plus B squared minus 2AB cosine C. Now remember, this lettering can get a little bit confusing when we're talking about our triangles. C squared is always the side we are looking for. So the side we're looking for here, I'll relabel it, but the side we're looking for here we called y. Okay, so I'm going to say my little c is the same thing as y. A and B are the next easiest thing to label. This is the side we're looking for. The cosine is the angle of the opposite side of the side we're looking for. The angle of the opposite side of the side we're looking for is 82. So I'm going to say the angle measure, big C, is 82. Okay. A and B are then just the other two sides of the triangle. I'm going to say that A is equal to 6, and B is equal to this one right here, which we already found the value of as 9.8 or 9.58. So B is equal to 9.58. Labeling this is the hardest part. From there on, we're just plugging stuff into our formula, which I will write in another color. So I'm going to plug in what I know. I don't know the value of y yet, so I get y squared is equal to A, I said was 6 squared, plus B, I said was 9.58 squared, minus 2 times A, which is 6, B, which is 9.58, and then cosine C, I said the angle measure I'm using is 82 because it's the opposite angle of the side we're trying to find. Now what I'm going to do next, I'm going to pop this all into my calculator, and I ended up getting y squared. I plugged just this side of the equation into my calculator exactly as I see it. And when I do that, I don't know how well y'all can see this. Probably not super well. That's what I got. So I plugged this entire side of the equation into my calculator. And when I plugged that in, I got 111.77. So I'm going to go is equal to 111.777. Okay. This is a tricky part. Y is not totally by itself here. So the very last thing we have to do is take the square root of both sides. You can leave your answer as equal to square root of 111.777, or if you pop that into your calculator, you'll get that it's about 10.6. So DC is equal to 10.6. Okay. Tricky part about these is just labeling what you plug into your formula correctly. Okay, very last one that we are going to go over together is this ACT problem on the bottom. Pretty straightforward right triangle trig question. We can use SOHCAHTOA here because we've got our right triangle. It's asking for the tangent of R. So tangent of R means this is my reference angle. So I'm labeling my opposite, adjacent, and hypotenuse based on this angle here. This is my opposite side, this is my adjacent side, and this is my hypotenuse. Tangent, remember, is our TOA. So the tangent of R is going to be equal to opposite, which is R, over adjacent, which is T. So we're just looking for RT. Retweet. Am I right? Wow, what a good note to end it on. If you have any questions, please email me or leave me a comment on Google Classroom. That's it. Signing off.